Hello and welcome back to my channel. One of you guys have mentioned in the comment box that you want me to make video on shear force and bending moment. So here we go. So first of all, what is a shear force and what is the bending moment? Let's say we have got a horizontal beam, okay? And on that horizontal beam, we are exerting a pressure from upwards, let's say force F. There are two ends of that beam, let's say A and B, and to support that beam, two reactive forces are exerting on it, let's say RA and RB, at point A and B respectively. Now, due to that force, let's say that beam splits into two parts, then that force is called shear force because it just shears. It splits the beam. And if due to that force it just bends, then due to that bending it is called bending force, and the moment because of that bending force is called bending moment. How can we evaluate any bending moment and how it is different from the bending force? So force is just a force, that means Newton, its unit is Newton. However, the moment is the force exerting along with the distance. We have to consider the distance as well. So let's say if between 2 points force is applying as F and the distance between the two points is A, then the moment will be force into A, okay, and that will be Newton meter or kilonewton meter, whatever it is. Distance multiply force, force multiply distance. Let's see with the diagram. This is a horizontal beam, okay. We have got 2 points. A force is applied here, okay. This is supported by two reactive forces, let's say RA and RB. If it splits, then shear force. If it bends, maybe like this or this, then it will be bending moment or bending force. Let's say the distance of this beam is L and the distance which is L by 2. So the force at A, the bending moment at A will be the force on A, which is RA multiply L by 2. Okay, this will be bending moment. Whenever we draw bending moment diagrams, BMD, or shearing force diagrams, SFDs, we have to bear some points in mind. Firstly, the sign conventions. When we talk about the shear force, all the forces, let's say we have the surface, the force surface, the surface which is at which point it is splitting, the leftward forces, all of them, if they are upwards, then we have to take positive sign. If they are downwards but exerting on the right hand side, then we have to take positive sign. And in contrast, when it is negative, when it is downwards to the left, we have to take negative. When it is upwards to the right side of the surface, shearing surface, it is again negative. For bending moment, we have to take, if the bend occurs clockwise to the surface, to the point, then it has to be taken as positive. If it exerts anti-clockwise but in right hand side, then positive. And in contrast, it is so. Now, I know it is, so far it is nothing, it's just simple concept. But now it's turn to apply this concept on in numericals, okay. So we have to consider these sign conventions whenever we draw a diagram, we calculate the shearing force and bending moment. Let's see in our next video. Bear with me, I will be making next video, and don't forget to subscribe, comment and share my channel. Thank you so much.